Okay, solving variables. We're going to be working with unknown variables, okay? And we have also our constant terms. Our goal here is to get any unlike terms on the other side. So we want all terms that are attached to a variable to be on one side of the equal sign. And on the other side, we want all of our constant terms. So what I'm going to do to start this is we're going to move over our variable to the left side of the equation. And I'm going to move all of our constant terms to the right. And we'll do this in one shot here. 0.7p. This negative 0.13p will become what? Positive 0.3p. Then we have our equal sign. When I move, we'll have 49.87 still. When I move 13 over, what does it become? Right. Now we're going to simplify. This 0.7 plus 0.3 will just become 1p. And when we add those two terms together,
63.29.
Is that what it is? Great. 63.29. We have to isolate p. So I got to divide, because it says 1 times p, we have to divide by that number. So we're going to divide this side by 1. Is that going to change anything? No. So we know p is 63.29. Next example. In this question, we have a fraction. It'll be easier if we're not working with the fraction. So we honestly want to move the denominator over here to the other side of the equation. Because it's a fraction, this line means division. So because it's divided by, in order to move the bottom part of this, when we move it over, it needs to be using what? Multiplication. So we're going to be multiplying by 8 times k minus 3 and bracket. So I'm going to rewrite this now. I move the denominator over, I have 5 is equal to 2 times 8 times k minus 3. So this is where our brackets came in handy. We have to use distributive property. This 8 has to be multiplied by both terms inside of the brackets. So 5 is equal to 2, 8k minus 24. We have to use distributive property again, because this is 2 times both terms in the brackets. So when we distribute that, we get 5 is equal to 16k minus 48. Okay? Now, like we did before, we want to get our variable by itself, so I'm going to move the constant to the other side. It will become positive. So we have 5 plus 48 is equal to 16k. 5 plus 48 will give us 53 is equal to 16k. Again, this is 16 times k. So in order to move it over, we have to divide by our 16. So k, in this case, will become 3.3. What is it? I'm going to try to, when I do this, I want you guys to round to 2 decimal places, so I'm not exactly sure what it says. 3.31. Perfect. 3.31. And there's our final answer for those two. Okay? I know I went through that one quick. Okay, our last example here. Fractions on both sides of the equation. Now, we can deal with this one at a time. We know that this is v divided by 7, or v plus 7 divided by 3. Because it's divided by, to go to the other side, we would multiply. And then we would do that again on this side. So, what I want you guys to recognize is, I want you to see these as fractions that are equivalent. And a fast way of simplifying fractions that are equivalent is called cross-multiplying. Okay? So this is where we can use that cross-multiplying, bringing the 2 to the top of the other equation, and bringing the 3 to the top of the other equation. When we do this, we'll be left with 3v is equal to, and this is 2 times v plus 7. We'll have to use distributive property here. 3v will give us 2v plus 14. Okay? We want the v's to all be on one side, so I'm going to move the 2v over. We'll get 3v subtract 2v is equal to 14. What is 3v subtract 2v? 1, or we could just write it as v. And there, we're already done. V is equal to 14.